Welcome to Study Loop.
All right, for this problem, we're given the map of two blocks, MA and MB, which are connected through a pulley and a string. We're given the kinetic coefficient of friction, mu k, between block A and the surface, the horizontal surface. We're given the radius of the pulley, its moment of inertia, and the distance d where the two blocks have traveled. And we're required to find the velocity when the two blocks have both traveled a distance d. So we will use energy conservation here. Initially, the system only has an energy that is due to the gravitational potential energy of block B. So suppose this is H. And B, G, H. Of course, block A also has a gravitational potential energy, but since it will always stay on the same horizontal plane, so its gravitational potential energy will not change during the whole process. Therefore, we can just ignore it. Okay, so that's energy initial. And then energy final is equal to the kinetic energy of three parts, including the kinetic energy of the block A, kinetic energy of the block B, and the rotational kinetic energy of the pulley. Okay, and furthermore, we know that the total energy for this problem is not really conserved due to the existence of friction. So E final minus E initial is equal to negative MA G mu K, which is the frictional force, multiplied by distance D. This is the work done by the frictional force, which we can see from the following. So the force felt by block A is a gravitational force, a normal force, which is equal to mg, a tension due to the strain, and also a frictional force, call it Ff. The value of Ff, by definition, is mu k times n. Since n equals mg, then Ff is simply mu k times mg. And recall that the work done by a force is the force multiplied by the distance under the effect of this force. So here, multiply at the work. All right, so combining the three equations, we can solve that the velocity. We still need another thing. So here, there's unknown omega, but we can re-express it in terms of the velocity and the radius of the pulley. So now, combining these three equations, we only have one unknown, that is v. So then we can solve for v to be square root of 2 mv minus ma mu k g d divided by ma plus mb plus I over r squared. Okay.